Students, in our last classes, we were solving the numericals from your section waves, which is there in your syllabus. We have done many numericals, and today also we will continue with the numericals only. So let's start with this numerical. I will just dictate the question and will explain it, then I will come to the solution. Okay, let's start. The equation of a simple harmonic oscillations of a source is y is equal to 10 into 10 to the power minus 2 sine 20 pi t and in meters. So I am writing, students, y equals to 10 into 10 to the power minus 2 sine 20 pi t, and this is given in terms of meters. Okay, that I am not writing. Okay, what is the next information you are getting? Find the displacement from the position of the equilibrium, the velocity and the acceleration of a point 10 meters away from the source of oscillation for a moment t equals to 3 seconds. So I am writing, students, the data that I am getting from the question. Okay. After the oscillation begins, the oscillation propagates with a velocity of 200 meter per second. Alright, that means, students, your V's value is also given. So I am writing here V equals to 200 meter per second. Okay. Yes. So yes, let's start the sum. So students, these data we have got from the question. So let us see what other data we can able to calculate from the data given in the question. Alright. So students, first consider this equation of y. This is displacement equation. Alright. So students, from this particular equation, can you recall that this particular equation, I told you all that you have to relate the equations that you will get in the exam with the equations that you have studied in the theory classes. So this equation is resembling your which original equation? A sin omega pi t, A sin omega t, isn't it? Just recall it, that very first equation of your wave motion chapter, isn't it? So we will consider that equation and we will formulate that what are the datas we can able to calculate. Alright, so let's start. So this resembles your omega, students, sin omega t. So I can write it, students, your omega will be equal to 20 pi, that I can write it from the given equation. Alright, so my omega is 20 pi. So from this omega I can able to calculate what? Your t's value, that is time period big T. So therefore t will be equal to 2 pi by omega, which is equal to 2 pi by 20 pi. That means 1 by 10 second, isn't it? Your time period t will become 2 pi by omega, and just calculate it, you will get 1 by 10 second. Clear? Very easy. So the time period we have calculated. Let's see what other parameters we can able to get. Okay. Just recall one formula, students, so that you can able to get your wavelength, your lambda part. Okay. So recall one formula, students, your lambda, where you will get the velocity as well as the time period. Alright. Why we are choosing this formula? Okay, let me write it, then I will explain. Lambda equals to, what is the formula of this lambda, students? I can write it as V into T, isn't it? If you just go through your previous formula pages, then you can able to see these. Alright, that your lambda can be written as the sum product of your V and T. you can ask that why I have chosen this formula. There are many other formulas to find the value for this lambda wavelength. Why I have chosen this, students? So that, see, to find out the lambda, I have written V and T. Why I have written V and T? Because V and T's values are given in the question. T's values you have calculated here, but V's values is given in the question. See, I have written on top. So yes, from these two V and T's, I can able to calculate lambda. That's why I've chosen this formula. If I would have chosen some other parameters whose data is not given in the question, then how will I be able to find out the value of this lambda? Clear? So that's why I've chosen this. So let's calculate this value of lambda. V's values is 200 into T is 1 by 10, which is equal to, just calculate, it will get as 20 meters. Clear? Okay. So my tabulation part is done. What parameters we can able to calculate. Now students, let's move on to the question part. Find the displacement from the position of the equilibrium, the velocity and the acceleration of a point 10 meters away from the source of oscillation. Clear? So for this part, your x values is given 10 meters away from the source. Just read the question once again. Okay, then I can able to write, yes, my x part is getting. So I can frame the equation of oscillation of the point, isn't it? So just let's write. So your y will be, that is the equation of oscillation of the point. Y is that a part, this is your a part, amplitude part, that is 10 into 10 to the power minus 2 sine within bracket 20 pi t, it is your omega t, minus 2 pi by 20 into 10. Okay, this is resembling what, students? That is your a sine, this is your omega t, minus 2 pi 2 pi by lambda t, isn't it? See, that's why I've written 2 pi into 10, because this will go in the up in the numerator, and this was there in the denominator, so you will get as 2 pi into 10 by 20. Okay, just go through the formula, students, and this will be meters as usually. So just calculate it, you will get as I'm writing.